graduating civil engineering student at József College. I don't speak English very well. My English is not so good. So I would like to read my presentation. I'm sorry. I would like to start my presentation with saying thank you to Dr. László, who is expert on ADCP measurements, as I prepared my presentation using his materials on the subject. Before speaking about the ADCP measurements, I would like to say a few words about the equipment itself. ADCP is a measurement tool using sound impulses. It operates with the Doppler effect. It is very effective in field measurements when connected to field laptop computer on which the variable software is running. So let's see what the Doppler effect is. The Doppler effect is the change which can be observed in the frequency of the sound wave, and at the same time in its wavelength, which develops because the source and the receiver are moving relative to each other. It is the same phenomenon which characterizes a train passing near us. The moving train sounds are getting lower because the wavelengths of the sound are getting longer and the frequencies are decreasing. During the operation, the equipment emits sound impulses into the water, which are reflected from the bottom and from the sediment particles moving with the current. As these particles have a distinct velocity, the sound waves arrive back to the transducers of the equipment with the frequency delay. These returning waves are then used the computation of the equipment, out of which it is possible to determine the velocity of water, the direction of the velocity vectors, as well as bottom depths. In the meantime, it is possible to take into account the movement of the ship on which the equipment is mounted, as well as the frequency and the velocity of sound in water. We must mention that the ADCP only measures the radial component of the velocity vector. That is why, in order to measure the velocity in 3 dimensions, we need more than one transducers. That is how the head of the ADCP equipment has more, in this case, 4 transducers, which are placed from 20 degrees angles with each other. In order to measure 3-dimensional velocity vectors, 3 transducers will be enough. The 4th one is there to have control over the 3 others. In this figure, the same time operation of the 4 transducers can be clearly shown. Let's compare the ADCP measurement with the traditional type of measurement using velocity meters. In case we are using a velocity meter, we have to take the equipment into the cross-section and perform the measurement in a given number of verticals in different depths. From the data, average velocities for the verticals are computed, and based on them, the average velocity for the whole section. On the other hand, ADCP can measure everything practically permanently across the line, making an angle with the cross-section. After the measurement, average velocity data are given for cells. In order to execute the measurements precisely, it is important to define the vertical angle of the equipment. It is the deviation from the upright position what we have to know in harder to be able to compensate it, if any. There is a built-in tool to check this, and the built-in electronic compass also. Before using this, we have to execute a calibration measurement to ensure its correctly operation. The electronic compass is very sensitive to the metallic components of the ship. So theoretically, we could all use it totally separated from metal object. This is not every time a feasible practice, so we need calibration for the compass tool. There is a special software which helps in this, while one must make complete circle with the boat in order to eliminate errors. Furthermore, we have to know how much the magnetic declination is. Magnetic declination, the angle between magnetic north, the direction at the north and the compass needle and true north. During our measurements, we set the magnetic declination to 3 degrees. Now I would like to say a few words about the determination of the true velocity. For this, first of all, the direction and the velocity of the ship is needed to be known. As the sound reflected by the bottom has a distorted frequency, it is possible to use it for determination of the ship velocity. This can only be done in case the reverber is stable. In case this precondition is not given, then we have to use a GPS receiver to determine the movement characteristic of the ship. As a final step, we can compute the real velocity of the water as a difference between the relative velocity measured by ADCP and the velocity of the ship. Finally, let's look at the theory of discharge determination with ADCP. As it can be well seen in the figure, the equipment is not able to measure discharge in every and each location. When to close the bottom or the surface, as well as near the shores, the ADCP will not measure but interpolate discharge. This way, we will get the discharge for the wall cross-section for the discharge measured in the different cells, plus the discharge interpolated for the surface and bottom zones, and the parts of the section close to the left and the right bank. During the project, we perform discharge measurements as well as the determination of velocity vector direction with ADCP. We measured the discharge in 7 cross-sections, 4 crossing each section. Velocity measurement also took place in all 7 sections, 5 vertical each section, 10 minutes every vertical. In order to have the velocity measurements and the sediment sampling activities in the same vertical, the ADCP group worked together with the sampling group. This way all our chemical, biological and sediment samples and the velocity data are from exactly the same coordinates. In practice, we used the ship on which we mounted the Rio Grande ADCP owned by our faculty. The ship measured altogether 7 sections, 4 crossing each, which gives 28 discharge results in a week, in May and in September alone. In this photo, the cooperation of the ADCP and sampling groups can be seen. The measuring ship is being fixed to the sampling ship. This way, the same time synchronous work is secured. Thank you for your attention. I'm wishing further useful and nice conference to you.